In this video, I'm going to build a unit circle, and I'm going to verbalize how you can logically think through the unit circle to build it, even if it is not rote memorized. So this is our ultimate goal up here, the unit circle with all of our radians and all of our xy coordinates. And all that we need to do in order to build this from memory is we need to know our special right triangle ratios, and we need to know that in radians, 100 degrees is equal to 1 pi. So starting with my special right triangles, down here at the bottom, if I have a 30, 60, 90, my side lengths are 1, radical 3, and then my hypotenuse is 2, with 1 being the shorter side. So the purple has the 60-degree angle on the lower left. I have the same triangle here in green. So if I put the 30 degrees in the lower left, then I have my long leg along the bottom, but it's still 1, radical 3, and 2. So the purple triangle and the green triangle are both 30, 60, 90s, just in a different position. And then my other special right triangle is a isosceles right triangle, 45, 45, 90. We often think of this as 1, 1, radical 2. But for the sake of the unit circle, I'm going to increase that by a scale factor of radical 2. So we can think of this as radical 2, and 2. So those are our special right triangles. I need to know those. And then I also need to know that my radians begin at, you can think of it like 3 o'clock. This point is the point 1, 0. So our unit circle is kind of like we've zoomed into the origin and we're just going 1 in each direction. So my radians begin at the point 1, 0, and then they travel counterclockwise around the circle. So I know my coordinates are each 1 in each direction. So we have 1, 0. Up here, we have 0, 1. On the left, we have negative 1, 0. And on the bottom, we have 0, negative 1. So we're kind of like we're zoomed into the coordinate grid with 0, 0 in the center, radius of 1. If we're traveling around counterclockwise, when we get to negative 1, 0, halfway around the circle, that is 1 pi. And then if we travel the rest of the way, a full lap of the circle is 2 pi in radians. You can remember this by thinking that the circumference is 2 pi r, and we're dealing with a circle that has 1 as its radius. So if we have a radius of 1, the circumference is 2 pi. 1 full lap of the circle in radians is also 2 pi. From here, we're going to be able to build everything else logically. So if 1/2 of the way around the circle is pi, 1/4 of the way would be pi over 2. And if I go 3/4 of the way, 1/2, 1/2, 1/2, then down here would be 3 pi over 2. So I already have my radians and my x and y coordinates at my 4, you kind of like my 4 corners. Now the next thing I'm going to build is I'm going to build quadrant 1. So quadrant 1 is the simplest quadrant up here. That's where everything is positive, both my x and my y. First, I'm going to put my 60-degree triangle in quadrant 1. So for my 60-degree triangle, 60 degrees fits in 183 times. So my 60-degree triangle would have a radian measure of pi over 3. So think of 60 degrees as like 1/3 of the way to 180, or 1/3 of the way to pi. And then when we are at pi over 3, actually, let's build all the rest of the pi's over 3. So we're going to have, that would be in quadrant 1. My 30-degree angle 30 degrees goes into 186 times. So my 30-degree angle is pi over 6. And then 45 degrees goes into 184 times. So my 45-degree angle would be pi over 4. So at that point, I've built the radians for quadrant 1. And next what I'm going to do is I'm going to put the x and the y coordinates in quadrant 1. So in quadrant 1, our x-coordinate is always going to be cosine, and our y-coordinate is going to be sine. The way you can remember that is imagine that you drop down a line like this. Cosine is always our adjacent over the hypotenuse, and you can see that our adjacent side is the x-axis. So cosine is our x value at every point. At pi over 3, so in my 60-degree triangle, my cosine of 60 degrees is 1/2, and my sine is radical 3 over 2. I can do the same thing with pi over 4. So for pi over 4, my cosine is radical 2 over 2. My sine is also radical 2 over 2. And then for 30 degrees, pi over 6, my cosine, which will be x, is radical 3 over 2. My sine is 1 over 2. So what you can see is that pi over 6 and pi over 3 are they are inverses of each other in quadrant 1. Like the x and y were switched in quadrant 1. Now that I've built quadrant 1, I can build the entire rest of the unit circle. So let's go in the other direction. Let's begin with pi over 6. Pi over 6 is going to have a coordinating value in all 3 of the other quadrants. So each quadrant has these reference angles 1 time. In quadrant 2, we want to think of going almost all the way to 1 pi, but being 1 reference angle short. So if my reference angle is pi over 6, if I got all the way to 1 pi, that would be 6 pi over 6. But if I'm 1 short of that, 6 pi over 6 minus 1 pi over 6, if I'm 1/6 before that, I'm going to have 5 pi over 6. So here, I'm going to have 5 pi over 6. And then if I were to go 180 degrees and then go farther into quadrant 3, I'd have 6 pi over 6 to get to 180 degrees, and I have an extra 30 degrees, so I'm going to have 7 pi over 6 down here. And then finally, if I go all of the way around my circle, that would have been 2 pi, which would be 12 pi over 6. But if I'm 1 short of that, 1 short of 12 pi over 6 would be 11 pi over 6. So I can figure out my radians in the other quadrants by thinking in comparison to pi or 2 pi. Am I 1 short of pi? Am I 1 extra beyond pi? Am I 1 short of 2 pi? Etc., etc., etc. If I got to 13 pi over 6, then I would just be continuing back into quadrant 1. So 13 pi over 6, then this would be 17 pi over 6, 19 pi over 6, etc., 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 as I continue to travel around the circle counterclockwise. So if I were to do the same thing with pi over 4, 4 pi over 4 minus 1 is 3 pi over 4. 4 pi over 4 plus 1/4 is 5 pi over 4. And 8 pi over 4 minus 1/4 is 7 pi over 4. And then finally, from my 60-degree reference angle, 3 pi over 3 minus 1/3 gives me 2 pi over 3. 3 pi over 3 plus 1/3 gives me 4 pi over 3. Oops. 4 pi over 3. And then a full circle would be 6 pi over 3, because that's 2 pi. If I take 1 away from that, I'm 1 short of a full circle. Then I have 5 pi over 3. And by this point, I've built my radian measures for the entire circle. Now that I have my radian measures, I just want to apply my x and y coordinates at each of these radians. For my x and y coordinates, we can see that each of these reference angles is still going to be the same triangle in each of the coordinates. It's just going in a different direction. So for instance, in quadrant 2, I still have the same x values and y values. I still have the same sine and cosine relationship. However, in quadrant 2, my x value is negative and my y value is positive. This means that my cosine will be negative and my sine will be positive. So for instance, for 2 pi over 3, now I have negative 1/2 radical 3 over 2. We see that's the same as in quadrant 1, except now my x is negative. If I continue into quadrant 3, in quadrant 3, x and y are both negative. So 4 pi over 3 would be negative 1/2, negative radical 3 over 2. And then in quadrant 4, x is positive, but y is negative. So I have 1/2 negative radical 3 over 2. So all of our x and y coordinates will be the same as in quadrant 1. We are just adjusting for negative x's and negative y's. So for radical 3 over 2, I have negative radical 2 over 2, radical 2 over 2. Quadrant 3, both are negative. Quadrant 4, x is positive, y is negative. And then finally, my pi over 6 reference angle. So pi over 6, for 5 pi over 6, x is negative. For 7 pi over 6, both are negative, x and y. And then for 11 pi over 6, x is positive, y is negative. Once I have done this, although this is not drawn perfectly to scale, you can see that I've constructed my entire unit circle. At every single point, I have the radian measures, I have an x value, I have a y value, and from that I know my sine and cosine for each of these values.